Okay, so we've got two relatively complex examples to do here. The first one, the key thing is don't lose your nerve in these. They always follow the same layout. So the mechanism for this one, I start with benzene, and it's going to be carbon dioxide, which is my electrophile. Don't forget your AS chemistry, oxygen delta minus, carbon delta plus. Out come your electrons. They're going to attack my carbon, because that's the plus thing. That gives me my intermediate, which is unhappy benzene, broken here, because he's got an H there, carbon there. If my electrons come here, how many bonds can carbon ever have? 4. That's forming another bond. That carbon's going to go, whoa, too many bonds. So those electrons will go to one of the oxygens there. So that becomes O minus, like so. The next step is that my delocalized ring is reformed, and that's formed by my hydrogen leaving and going on its merry way. That leaves me with that plus H plus. So the final step is that my lone pair of electrons goes to the hydrogen to form benzoic acid. Like so. Now, that's as hard as you're going to get in the A2 paper. In fact, even if they give you this, they're going to give you part of this, and you just fill it in as you go along. I've not seen a question where they just said, oh, here's a reaction to it. So you'll be happy with this one. Right. The next one is a really, really exciting reaction. Chemists get very excited about this one. Can anybody see why you'd be excited about this one? What am I forming there and there? That's a carbon. Formed a carbon-carbon bond, which is really, really rare for chemists to do. I know you're not very excited. Chemists get very excited about forming carbon-carbon bonds. Okay. So the first thing, show the formation of the electrophile. So, electrophile formation. Aluminium trichloride now my catalyst, but you know, we can cope with that. CH3, C, CH3, CH3, Cl, plus aluminium trichloride. From our previous mechanisms, it's going to break this bond. It's going to give me CH3C plus AlCl4 minus. Got my electrophile. Let's do the mechanism. There's my benzene boy. Here's my electrophile. Same routine, nothing changes. Out come my electrons to the carbon. They give me the intermediate with the positive charge there, H there, form my carbon-carbon bond there, very exciting. The H goes way I'm off to form my final product. And H plus. And the final step I need to do is to regenerate my catalyst, which means I've got to get to HCl, so these two join together. So regen catalyst is going to be AlCl4 minus plus H plus goes to AlCl3 plus HCl. Like so. And again, that's as hard as you'd ever get. Now the tricky one, really, was this bit, a little bit stretch and challenge. How does that aluminium trichloride act? Sodium chloride won't touch it, magnesium chloride won't touch it. What's special about aluminium trichloride? Well, what's going to be the charge? Now, aluminium trichloride has a very, very low melting point. What would that tell you about its structure? If it's got a very low melting point, is it going to be ionic? What's it going to be? Covalent, and the type of structure is going to be simple. Yeah, simple molecular. Let's try and do a dot and cross diagram for that. I've got aluminium. How many electrons does aluminium got in its outer shell? 3. Like so. So he forms his bonds with chlorine, like so. What's going to be the charge? Remember, this is going to be, if we drew it out as little lines, Al, chlorine, 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 this aluminium is going to have a very, very high charge, isn't he? He's a very, very small ion with a high charge. So when he meets a chlorine, he's going to be attracted, that chlorine is going to be attracted to that aluminium. So what type of bond, if I now had to draw aluminium with 4 chlorines on, how could Cl- bond in with that aluminium? What type of bond could I have? Brilliant, dative covalent. So here comes my chlorine, called the dative covalent bond with that, and that gives me my AlCl4- ion. So it's the fact that aluminium is highly charged, and he's got this possibility, because he's so highly charged, it's actually a covalent molecule rather than ionic. And he can form this AlCl4- species, which of course is regenerated in that last step. So that's a little bit about how aluminium trichloride, and iron works in exactly the same way.